So when we call vector integration, the integration originates from the vectors. Of course, the integrand may not be a vector. For example, if we take two vectors a and b, the dot product a dot b is a scalar function, and a dot b denotes the component of magnitude of a along b. What I am saying, a dot b will denote the magnitude of the component of the vector a in the direction of b. If you take a cross b, it is a vector perpendicular to both a and b. So when you take integration of a dot b, it is also a vector integration, but here the integrand a dot b is a scalar function. If you take integration of a cross b, here the integrand is a vector and it can be integrated. Similarly, when we call vector integration of a force F, the force F is a vector quantity and a small element of the given line, a small tangent or a small given line of the element dr, it may be taken as a vector. So f of r dot dr will denote a scalar function that is the magnitude of component of f along the vector dr, and f cross dr will denote the vector perpendicular to both f and dr. Now I used to discuss the terms of dr. What is dr? Let us take a point P in a 3D space. That is, let us take the position of the point P with respect to three coordinates x, y, z. Then the point P is described by the coordinates of x, y, z. So P is equal to P of x, y, z is a point in a space. X is the first component, y is the second component, and z is the third component. The shortest distance from the origin O to the point P, that is length OP, is called as radial vector or the radius vector and is denoted by r. Again we can write r as r is equal to x, y, z, or in other words, when we write it in terms of a vector, we write it as r is equal to xi plus yj plus zk. So when we want to differentiate a vector, we differentiate its components. In other words, derivative of a vector is nothing but derivative of its component in the same order. So as r is equal to xi plus yj plus zk, where I, jk are unit vectors along the x-axis, y-axis and z-axis, its differential coefficient dr can be written as dr is equal to dx into I plus dy into j plus dz into k. So dr, it is a small element of the vector r and it is along the line. Now if we consider the end point of the vector r, it is on a line or on a curve that is denoted by f of r. So if f of r represents a line or a curve, every point on the line is nothing but end point of a radius vector r. In other words, we can say that the radius vector has the initial point at the origin and the radius vector has the end point at the line. So dr will be a small element along the line. It is a vector quantity. The form f of r dot dr, as I told earlier, it is the magnitude of the component of f of r along dr. It is a scalar function. F of r dot dr is a scalar function. Hence its integration along a line will be the integration of magnitude of component of f along the same line. Of course, if f denotes the force F, then dr denotes the distance. So f dot dr will denote the work done. The scalar function f of r dot dr is the integrand of integration over c f of r dot dr, and this integrand will be converted to a function of single variable by using the given equation of the line. That is along which we need to integrate. Given equation of the line in the sense, here the line is the relation between variables. The line is nothing but the equation of variables, equation containing variables, and then the integrand f of r dot dr will be converted to a function of single variable and integrated between the required limits. So let us consider one example in xy plane. Let us consider one example in a xy plane, that is, here the force F is also defined in terms of a functions of x and y. Here F is taken as 3x square minus y into I plus xy into z, where, as I told earlier, I denotes the unit vector along x-axis, j denotes unit vector along y-axis. We need to evaluate integration of f of r dot dr along the line y is equal to x square between the points 0, 0 and 2, 4. You may note that in the first point x value is 0, y value is 0. In the second point 2, 4, y value is 4 and x value is 2. So we need to integrate along the line y is equal to x square, that is the parabola between the points x is equal to 0 to x is equal to 2. So we have f is equal to 3x square minus y into I plus xy into j, and we take r is equal to xi plus yj in xy plane, and dr is equal to dx into I plus dy into j. So f of r dot dr will denote 3x square minus y into dx plus xy into dy. So f of r dot dr is a scalar function of two variables xy and its differential coefficients dx dy. We will convert this function of two variables into a function of single variable by using the equation of the given line. Here the equation of the given line is y is equal to x square. When you differentiate both sides, we have dy is equal to 2x dx, and therefore f of r dot dr will be converted as a function of single variable by substituting y is equal to x square, or by replacing y by x square and dy by 2x dx in the integrand. So integration over c f of r dot dr is equal to integration along C it is 2x square plus 2 times x to the power 4 into dx, or in other words integration of 2 times x square plus x to the power 4 with respect to x, where x changing from 0 to 2, and when you integrate you will get the value as 272 divided by 15. Let us take another one example. You have let integration over C f of r dot dr along the straight line between the points 0 0 and 1 1, that is along the straight line connecting the points 0 0 and 1 1, where f is given as 3x square minus y into I plus xz into j plus x square into k. Note that here f is a function of three variables x, y, z. So the force F is in XYZ space or 3D space. Hence we take R is equal to Xi plus Yj plus Zk, and its differential coefficient will be dr is equal to dx into I plus dy into j plus dz into k. With this f and dr, we calculate f dot dr as 3x minus y into dx plus xz into dy plus x square into dz. X square into dz. You must note that here a small mistake is occurred, that is in writing f I have skipped one term, that is 3x square minus y, and here x square I need to write at the end. So you please correct it. 3x square minus y into I plus xz into j plus x square into k is the given function f. So f dot dr will be 3x square minus y into dx plus xz into dy plus x square into dz. Hence integration over C f of r dot dr is written as integration over C 3x square minus y into dx plus xz into dy plus x square into dz. Now we need to convert the integrand 3x square minus y into dx plus xz into dy plus x square into dz as a function of single variable consisting of its differential coefficient dx. For this we use the equation of the straight line from 0 0 to 1 1. The equation of the straight line in 3D space connecting the 2 points x1 y1 z1 and x2 y2 z2 is given by x minus x1 divided by x2 minus 1 is equal to y2 minus y1 is equal to y minus y1 divided by y2 minus y1, and this is equals to z minus z1 divided by z2 minus z1. So x1 y1 z1 as the point 0 0 and x2 y2 z2 is equal to the point 1 1. So we take the equation of the line as x minus 0 divided by 1 minus 0 is equal to y minus 0 divided by 1 minus 0 is equal to z minus 0 divided by z minus 1 minus 0, and therefore it becomes x is equal to y is equal to z. So this is the equation of the straight line joining 0 0 to 1 1. X is equal to y, y is equal to z. So if you differentiate, you see that dx is equal to dy is equal to dz. So in the above integrand of integral 1, in the above integral of integrand 1, we substitute x for y, x for z, and both dy and dz are replaced by dx. X also ranges from 0 to 1, so I can write, substituting all these in 1, integration from 0 to 1 3x square minus x into dx plus x square dx plus x square into dx, and this gives you integration from 0 to 1 5x square minus x dx, which is a function of single variable consisting its differential coefficient, and it can be integrated very easily, whose value is 7 by 6.